Welcome to episode 339 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I am good, Rob. How you doing?
I'm doing good. I saw you released your latest C++ weekly about the constexpr issue you finally figured out, right?
Yes. And actually, that's what I was just responding to someone about a moment ago before we got on the
Doing
call
someone
here.
wrong on the internet?
So it's interesting because, like I said, it took me like 5 years to come up with a good solution to this. That's what was the whole point of the episode. The number of people who commented initially, because I don't read all the comments all the time. It's far too many, but I'll often see all the comments that come in the first couple of hours. And almost everyone said, wow, I just did an issue like this yesterday. I've been looking for a solution to this problem. Like, thanks. Lots of people were like, wow, thanks for this solution. A couple of people were like, well, I think the language should work differently. Well, I mean, it doesn't. So, okay. And then I got 2 bug reports open on the project, basically, because I did release the tool open source, like I said I would in the video. I got 2 bug reports, 1 bug report and 1 pull request, both telling me that I was doing an unnecessary extra step because, of course, the compiler won't do the work twice.
But you showed it in the video.
I showed in the video.
Yeah.
Well, I don't prove that it has to do the work twice in the video. But then the person who opened the bug report actually proved themselves wrong. Shortly after that, they posted another comment like, I just tested it. Oops, basically.
Gotcha.
So I was just using Fred Tingaud's build bench, which we've mentioned on the show before, to do a quick comparison between the different options so that, yes, in fact, the compiler does actually do the work multiple times. So now I have like a handy data point for when the topic comes up again. I can be like, well, until compilers change, this is the situation that we are currently in.
Very cool. Okay, well, at the top of every episode, I like to read a piece of feedback. Jason, you brought up this one, which was someone emailing you about both CppCast and your YouTube channel. And this is from Rakesh saying, I use CppCast to catch up on the latest in C++. You guys are doing a really good job here. I had one comment that you could do to improve in the cast, and that is include more notes or links. Many times I don't even know about the things you talk about, like most recently, Jakob talking about Conan. I wasn't even sure how to spell it out, but on instinct, I searched this and did indeed find out that it is exactly how it's spelled. I think things like that would be really useful for developers.
I responded to Rakesh privately saying we do try to put these things in the notes. It's hard for us to because we talk about a lot.
Yeah. So I mean, obviously, we always have like a couple news items, and we always put those in the show notes. But if something just kind of like organically comes up during the conversation, we kind of need to remember to make a note, and sometimes we forget to add it to the show notes.
Yeah.
But definitely we'll always try to be better about that, and always try to include as much as we can in the show notes. Yeah. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. Don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Robert Seacord. Robert is standardization lead at Woven Planet, where he works with Toyota and its suppliers to accelerate software development while improving quality. Robert is the author of several books on C, C++, and Java programming, including Effective C. Robert, welcome to the show.
What do you mean? What is standardization lead? What is your job and title?
Yeah, that's a very good question. I just started this week, so mostly I don't know, but it's basically to try to standardize internal software development practices and also to try to influence some external standards like C and C++ and get involved with some of the security and safety groups and MISRA, things like that.
Okay.
Wow. Well, hopefully you enjoy the new role that you have found.
Yeah, so far the first 2 days have been great, and on my third day, I get to talk to you guys. So what could be better?
Awesome.
Great. Well, Robert, we got a couple news articles to discuss. Feel free to comment on any of these. Then we'll start talking more about your books and your work on secure coding and other things, okay?
Yeah, sounds good.
Okay, so this first one is a blog post on Vittorio Romeo's website, and this is wordle compile time Wordle in C++ 20. And he's got a nice video of playing Wordle in this C++ code that he wrote, fully, constexpr code. I think Wordle is kind of phasing out, but it was kind of fun to see this.
Yeah, just barely missed the fad there.
Yeah.
Did you get into Wordle by any chance, Robert?
I did. Oh, go ahead, Robert.
Either one of you.
Oh yeah, I guess you're Rob and I'm Robert for the purpose of this recording. But I went. I was playing it for maybe 6 or 7 days, and then I got a little bit tired of it. And it's hard to avoid that temptation to bore your friends by posting your result online. So
Definitely done that. Yeah.
So,
was there anything particularly interesting about the code? It was definitely cool to see.
I didn't dig into the code personally. I just watched the video. I kind of wish that it had some way of automatically forwarding state to the next instantiation of the compiler.
Yeah. So with
That would be
difficult. With every time you run constexpr Wordle, you need to send in the state as a compiler flag so that it can run again and update with your new guess.
I guess I could do one of those has includes to see if a previous state header file exists, and if it does, automatically include that and ignore the seed that you explicitly passed in or something. Then you just have to delete the state file each time. So it could write its own. No, it can't write its own state file during compilation. Curses. When are we going to get things like hash embed and stuff?
Yeah. That'd be nice. Okay.
John Heed is working on it for C at least, and I don't know how that's progressing in C++.
It's definitely not going to make it into 23 for C++. I think at least at one point, John Heed's hope was to get it accepted in C so that C++ had no choice but to accept it. So.
Yeah, we looked at it in the last meeting, and it was sort of big and scary enough that a lot of the WG14 committee members got a little bit afraid of it. So we're gonna have to see it again, and I'm not sure what approach John Heed's going to take, but maybe if it could be sort of reasonably cut down, that might make it sort of more digestible and more acceptable to the C committee at least.
I swear it's about once every other week or so that I think, man, I wish I had a way of easily including data in here without having to do, some pre-processing step or some weird, build system magic or something like that.
Yeah, I've had to enter a few large arrays from time to time, and it's not any fun.
Yeah. So you're involved actively in the C committee, but not the C++ committee. Is that right?
Yeah, I'm getting there. So I think my last involvement with C++ is I hosted a meeting here in Pittsburgh. I don't even know how long ago it was, maybe 10 years ago. That it was the year that the Pittsburgh Penguins and the Pittsburgh Steelers both won the championship. So,
oh my.
Thanks for giving me a chance to get that in there. So right now I'm in the SC22 compatibility group that's led by Aaron Ballman. So I'm gonna get my feet wet there, and I'm also joined the SSRG, the safety and security group within C++. So yeah, pretty soon I'll have to get my Insight memberships in for Underwoven Planet. Kind of change my organization. So this will be, I guess, the third organization I've represented at in the language committees.
Okay.
A good segue to our next news item. And now, Rob, I feel like I may have made a mistake by putting this in here. Have we already discussed the January mailing of C++? C++?
I am wondering that because this was just a week ago. So maybe we haven't.
I don't know. But for the sake of distinguishing the Robs in the room, Robert, there's a bunch of SG22 compatibility things in the last ISO C++ mailing.
Yeah, we're looking at a bunch of things. Of course, the timing's not great now because all sort of new proposals for C23 are past due. So so we had some compatibility papers that made it in, and to a certain extent, I've become the designated chump for reformatting C++ papers for C. So I did a UAX 31 paper that got adopted into C. So we're going to use the same format for identifiers for you and as C++. And we just discovered this past week that we managed to disallow the use of Unicode characters in identifiers that weren't entered through universal character names. So now I'm just before this podcast began, I was working on a paper to fix that problem. So presumably those sort of defects can be still looked at, because that might be a pretty significant breaking change for C23 if we don't address that. And I actually worked with my new boss, JF Bastian, on a volatile paper from.
Oh, your boss is J.
That's yeah.
JF. Yes.
Yeah. So you can express your condolences in whatever form you like, but it's yeah. I mean, I can't think of the last time I had a manager who could discuss things technically in depth. So this might be a kind of a new experience for me. So far it's been great. We actually had and I don't mean to segue you yet, but we had a chat about integers last night because he is actually in Tokyo and I'm in Pittsburgh. So we talk mostly in the morning and the evening. Yeah, so I just want to make sure we were kind of aligned with the same views on integers, and it turned out we are. So that was good.
Well, you should take advantage of this time frame where he's recently become a manager, but still knows technical things and can discuss them with you. Because who knows how long that'll last before he loses that ability. I'm sorry, I'm being terrible here.
No, I get the joke. I mean, we used to have manager training, but as a stopgap measure, we'd bang their head in the door a few times to, kind of slightly lobotomize them so they could function, as a manager.
So, on a more serious note, though, I have been very curious about this basic lambdas for C proposal that's been going around in the C committee. And now if it gets approved in C, we have to do something about it. It's one of these compatibility papers in the ISO mailing list. Just curious if you have any insight or opinion on C lambdas.
Yeah, I mean, I like the idea of doing something. It's a little bit strange, just over the past 6 months, even the C committee has become a little bit more. What's the opposite of progressive? Reactive.
Progressive?
conservative, regressive. Yeah.
Okay.
And so we've kind of added some new members who think, C is fine the way it is. And maybe, we'd gone too far and we should backtrack to C89. And, and so it's become a little bit harder to adopt a C++ feature. So Jens Gusted, he presented sort of a collection of papers all around the topic of, generic programming in C, to kind of improve generic programming in C, which is, really terrible as it is, really broken. And, they didn't go very well. So he's going to make some changes and bring them back again. But I'm very much in favor of lambdas because I've been proposing a kind of a defer mechanism for C that's based on the Go language. And, everyone agrees that the defer mechanism looks a lot better with lambdas, but not everyone agrees that that's a reason to introduce lambdas. So hopefully we can make some progress. Hopefully we do get that into C23.
I'm sorry, can you explain what you mean by a defer mechanism? I'm not familiar with that.
Yeah. So it's a new keyword, defer. And basically, and it's really based closely on the Go mechanism. So what happens is you allocate a resource, memory, open a file, and then if that allocation succeeds, then you might say defer the free of the memory or the free of closing the file. And what will happen is when you exit something, that code would then be executed and that resource would be released.
Okay.
And this is we don't have all the fancy C++ stuff in C, right? So we don't have destructors and we don't have exceptions and all these things. And so, I think this goes a long way to kind of addressing resource management in C. And when the idea came up, it really had a lot of immediate support. People really got behind it. And so WG14 voted to have to produce a technical report that kind of documents the feature, because this is a new feature without much implementation experience. So we're gonna pursue that TR after C23 is wrapped up. And there's a lot of excitement because it's something kind of new. And a lot of the enhancements we're making to C are almost bug fixes. If Aaron were here, he'd say, "Oh, we've got attributes," but I don't know. I think this new C23 is kind of lacking any really big splashy new feature that's going to get people's attention.
Well, that's, like you kind of said before, it's kind of how C rolls, slower adoption even than C++, I feel like.
Oh, yeah. I mean, in the C committee, we consider C++ to be an experimental language. So there's that.
Okay. As far as, I guess going back to the news, the next thing we have is another ISO paper, and I think this one just did get voted in, and this is making std unique pointer constexpr.
Yeah, Andreas Svertig, I think it's his first paper accepted into the standard.
Yeah, very cool. You have any plans for what you'll be able to do with this one, Jason?
Well, the experimental code that I was working on immediately before this call to do compile time benchmarks, I had to basically roll my own constexpr unique pointer effectively for what I needed to do, because The only shipping compiler that supports constexpr vector and string is Visual Studio. So I had to hand roll something real quick that kind of smelled like a constexpr vector for the sake of proving what I needed to for this compile time stuff.
Oh, okay.
So yes, it would have been easier if I had unique pointer.
Right. All right. And then the last thing we have here is Reiner Grimm, who we mentioned a few weeks ago, is doing this training, is also putting out that you can get some of his books available with a coupon, a bundle of C++ collection for half the price, and all proceeds are going to go towards Ukraine, which is great.
Yeah.
Yeah, those guys need all the help we can give them.
Yeah, absolutely. I check the news about it every morning. It seems like they're still able to hold the cities and everything. So I hope things are going well. I hope it's over soon.
Yeah, I feel like the State of the Union address felt overly optimistic at the moment, but hopefully everything does work out well for the Ukrainian citizens.
Yeah, I think they've been exceeding expectations,
Right.
but we'll see what happens. I think in the long run, at least, they'll win. They'll be successful, but a lot of pain and suffering before that goal is achieved. So I might as well get this plug in, but there's also a humble bundle available right now from No Starch Press that includes my Effective C book and some other books, and the proceeds of that also go to charity. Although I didn't check to see what the charity was, I don't think it's gonna go to Ukraine, but I could be wrong.
Yeah, and Humble Bundle is they're always doing different charities, usually like selling video games and things like that at a heavy discount. So that's pretty cool. I'll have to get the link from you for that for the show notes. Well, I guess on the subject of your book, you have written a few. Do you want to tell us a little bit about some of the highlights of the different books you've worked on?
Yeah, writing books is interesting. It's kind of, women have this hormone that's released after they have a child that makes them forget how awful a process that is. And I think authors have the same thing in some sense, because every time I finish a book, the first thing I say is never again, and then I go ahead and write another one. But yeah, so I don't know. I had some early books on kind of software process type things, and 2003 I moved into the Cert organization at Carnegie Mellon University's Software Engineering Institute, and decided C was where all the problems were, and so I kind of reinvested myself into C language programming and wound up writing secure coding in C and C++, which has been a pretty successful book. It's still still selling pretty well. It's in a second edition now, but it's still going pretty well. And a few years ago, I was up at Recon in Montreal, which is a reverse engineering conference, and I gave a talk on dangerous optimizations in C, or as David Keaton calls them, optimizations. And Bill from No Starch, he grabbed me in the hallway, and he wouldn't stop irritating me until I agreed to write a book for him. So that's how Effective C came about. But yeah, it's been a good product. I think people like it. Everyone's having a hard time figuring out if it's an introductory book or not. I mean, so it starts at the beginning and it covers everything, which makes it an introductory book. But I didn't want to teach people how to do things wrong and have them need to relearn how to do them correctly. So it goes into the kind of the necessary level of detail which is deeper than you would normally find in a crash course or introductory book. But people do seem to like it, although they're still sort of seem to be confused about who the audience for the book is.
Mm-hmm.
That's an interesting comment, and something I've thought about, and something we've discussed a little bit with other authors on the show before, Rob, was, if you want to show a simple example, but you don't want to show bad practice and bad code at the beginning of the book, what do? Do you show the simple example that's bad practice and put a comment saying this is terrible, don't ever actually do it this way, we'll fix it in the next chapter? Or do you show enough background detail that you can show the best practice at the first page? And it sounds like that's something you kind of tried to balance from what you just said.
Yeah, I'm not sure I tried to balance it. I mean, I went for kind of just trying to have good code most of the time. I guess, I'm thinking my intro chapter now, and I did have kind of a, here's a first pass at this, and here's a second pass at this, and here's a third pass at this. So I incrementally sort of improved the first example. But, I before this, I did the Cert C secure coding standard, which I forgot to mention. That was also published by S and Wesley. But we developed that on a wiki at the SEI. And so we had, we had sort of anti-pattern code, and then we had good code. And so we just put the anti-pattern code in sort of a pink box, and the good code in a blue box or green box to kind of try to discourage people from taking the bad code and cut and pasting it into their systems. But there's always this risk of showing novice programmers bad code, because they might not realize it's bad code, and they might decide to reproduce it in their system.
You just gave me a wonderfully terrible idea. I'm thinking about your anti-pattern code in its pink box, right? And then you have other code that's the same color as the background intermixed with the code that you're trying to show. So it's like one of those things, like from an old school, like a back of a cereal box, where you had to have the decoder, like the red filter, right? So if someone were to copy and paste the bad example, when they paste it into the thing, all of the code that they couldn't see is now also in there, and the example's broken, so they can't even try to use the bad example.
Oh, that sounds like fun. Sounds like a kind of a use case for Biddy.
Is that
Biddy?
Oh, Biddy is it's a cute term for bi-directional Unicode characters, right? So they're
okay.
they're these Unicode characters that let you kind of reorder the characters in your source code, or even the tokens in your source code. And what people have been demonstrating recently is that you can put these Biddy characters into comment because it's not parsed, obviously, and basically take code that looks like it's actual code, but it's code that's in the comment, right? So you might have a line of code that says, if admin do this, very secure thing, but in reality, the test to see if your admin is in the comment. So it's not actually compiled into the executable, although the source code appears to have it there. And so this is what the security, the C++ security and safety group is looking at right now, addressing that, and various homoglyph type attacks where you've got Greek characters which look the same as Latin characters, and so you think you're accessing one identifier, but really it's a different identifier. So addressing a range of security issues around Unicode.
Both Facebook and YouTube say that C++ has an excessive number of special characters in it, just C++ by itself. This is something I've run into several times, and I'm trying to post videos and articles and stuff. And so ended up having to find a plus character from Inuit language symbols to be able to actually put in. So that's how C++ Weekly is C++ Weekly on YouTube, because it's not actually pluses. So
oh, clever. Yeah, I might write my next C++ program in Ugaritic or something. But yeah, yeah, there probably are too many characters in C++ and C, and so that's kind of what these new there's papers for C and C++ which parallel Unicode Annex 39, which tries to kind of address Unicode security, and part of that is to sort of further restrict the set of characters. And I think it's probably too late for C. I mean, C has discussed it, and so yeah, it's too late for this, which is kind of unfortunate because, as we go forward and we expand the use of Unicode, and various compilers start supporting UTF-8. I mean, they're already supporting UTF-8. People start to use these characters, and then down the road, we might have to take them away, which is going to obviously break existing code. So it's a no bueno situation, I suppose.
So I think we definitely want to talk more about secure coding, but before we dive deeper into that, I did want to back up and give you a chance to talk about integers, because when we were first setting up the interview, you said you definitely wanted to talk about integers and how you thought the C++ community was not handling integers well. Is that right?
Yeah, I thought, what the hell? I'm addressing C++ community. I might as well start a huge fight. Yeah, like some years ago, I sent a proposal to an ICSE conference, International Conference Software Engineering, do an 8-hour tutorial on integers, and they turned it down, of course, right? Because who in their right mind would sign up for that? But the guy, emailed me and he said, can you really talk about integers for 8 hours? And I said, sure. I'll just talk really fast and skip the boring bits. So yeah, one of the issues I've been seeing, John Heat brought us a paper on bit operations, to try to introduce them into C, rotate operations and so forth, and they all had signed int for the count, right? And count is something that a count is something where you have 0 items, and then you have you get more items, right? But you never have -5 apples or -5 bits, right? And so I think the C way to look at signed integers is that you'll use a signed integer if you're trying to represent a value which can have both positive and negative quantities. But I think C++ has a different, although incorrect view, which is that unsigned integers don't really give you all that much greater range. So so the range is not that much of an issue, and they tend to, I think, look at unsigned integers as something which will have modulo behavior, as opposed to something that's used to represent only 0 and positive values. And the other thing that seems to be driving C++ is this sort of mistaken belief that so signed integer overflow is undefined behavior, right? We all know that. But it seems like a lot of C++ decisions are driven by the idea that because signed integer overflow is undefined behavior, we can have tooling which then does something different for that undefined behavior. So when it detects the overflow, it can trap or do something different. And that sort of leads C++ to specify APIs that use signed int instead of unsigned int in places, for things like count, where unsigned is more appropriate. with this idea that we're going to encourage our users to write bad code so that we can detect that bad code in tooling, right? And that seems really misguided, right? So I think the thing that people are really missing is that it's okay to write non-conforming tooling, right? So if you look at UBSAN, UBSAN has a flag to trap on unsigned integer wraparound, right? So they've implemented those tests. You can do that, right? Not every not every implementation, not every set of flags that you pass to your compiler invocation has to be conforming to the standard. And there are compilers, like IBM, which by default are non-conforming to the standard. I mean, there are sets of flags you can use to have a conforming implementation, but by default, their implementation is not. They actually treat unsigned integer wraparound as undefined behavior to improve their ability to optimize loops and so forth. And that community has embraced that behavior, even though it is non-conforming.
I agree that I have heard so many of these arguments about signed versus unsigned, and a lot of them stem from one particular CppCon talk that was given probably about 5 years ago now, that talks about unsigned integer math being slower, and partially it comes down to the fact that the compiler can't eliminate some certain cases of undefined behavior. So in some cases, if you use signed integer math, it's faster. And so this is the kind of thing that I've had to deal with several times, because in my role as an educator and YouTuber and whatever, people will come up to me and like, well, didn't you see that one video? Don't you know that signed integer math is slower? And I'm like, sure, in that one hyper specific optimizer case it is, but then I see people who, because they have this in the back of their minds, they take all the places where the standard currently does unsigned integers, like the size of a vector or whatever, and then they just blindly cast that to an int. And they actually pay a small but real cost of doing a conversion from an unsigned 64-bit int to a signed 32-bit int. On most platforms, it has to add a couple of instructions, when it's actually faster to just stick with the type that the standard already gave you. So my mentality personally has always just been to stick with the type that I was given. I don't really care. You gave me an unsigned size, I'm going to use an unsigned size.
Yeah, I mean, the argument in this talk appears to be, hey, if your code is wrong and have undefined behavior, we can make that code really fast, And I mean, I sort of disagree with that whole premise, right? That, hey, if you don't care what sort of, result you get, hey, we can make it super fast. So I would say unsigned integers are faster in many situations where you want a correct result. And, even things like, signed integer, say a remainder operation with signed integers can result in overflow, which is surprising to most everyone.
Okay.
You want me to run through that?
Yeah. Why not? Go for it.
Yeah. So division, right? If you have int min divided by -1 on a two's complement architecture, which is now all C23 and C++ support, right. That will overflow, right? Because two's complement is this asymmetrical range where there's always one more negative value than positive value, right? So if you take the minimum value and divide it by -1, you're going to produce a value that can't be represented in that sign type, right? So you'll have overflow. Okay. So it turns out that if you replace that division with a remainder operation, you have int min remainder -1. Mathematically, that produces 0, which say, the preprocessor will have no problem giving you a 0. But
so literally like 0 modulus -1. Is that what we're saying?
No, int min.
Intimate. Okay.
Yeah.
Sorry.
So the minimum value, you can represent as that signed integer type.
Okay.
If you divide that by -1, right, it's going to be too large to represent a 2's complement number, because 2's complement always has one more negative value that can be represented than positive, because 0 is basically represented as a positive representation, right? 2's complement doesn't have -0, right? Like 1's complement or sign of magnitude representation would have. So when you go to remainder, and I'm not going to say modulo because I don't believe it's a modulo operation. In the C standard, again, which I'm more familiar with, in the text of the standard, it never says what the name of that operator is. But if you look in the index, it's referred to as the remainder operator, and it does actually give the behavior remainder operator. So int min remainder -1, mathematically that should produce a 0, right? Any number divided by -1 will have no fractional part remaining, right? But on, say, x86-32 on Intel processors, remainder is implemented as division, as a sort of a, so you'll divide and then you'll get the remainder. And so it'll generate an IDIV instruction. And the IDIV instruction, if it's given int min divided by -1, it will overflow. So the remainder operation on Intel platforms and other platforms will actually overflow and result in a fault. So that is, it used to be implicit undefined behavior in C, meaning we forgot to document it as undefined behavior. But now it's actually since I can't remember, since C11 or C17. I think C11, it's become explicit undefined behavior.
That's interesting too, because sometimes you have people come up that are like, well, why don't we just eliminate all the cases of undefined behavior? And if I'm hearing you right, you're effectively saying this is also undefined behavior at the CPU architecture level.
Yeah. I mean, undefined behavior is very misunderstood. I mean, people tend to think of it as errors in the standard, but undefined behavior is all very intentional. My primary concern has been safety and security, and I've written at least a couple papers, maybe more, which have actually introduced undefined behaviors into the C standard. The first one being making remainder operations explicitly undefined for those values. But undefined behavior is really there for one of three reasons, right? So the first reason is because you have a defect that is difficult, potentially impossible to diagnose, right? So the standard can't require a compiler to diagnose it, so it makes it undefined behavior, which leads to the possibility that it will be undiagnosed, and the code will just do some random sort of thing. In C, we used to say it could go off and play the game of life. I think C++ refers to nasal demons, just because of the more satanic nature of the C++ committee. But that's clearly a joke. So the second thing undefined behavior does is it just basically allows for the implementation behaviors, right? So if implementations, if processors can vary in how they perform an operation, C and C++ don't want to dictate, int min remainder -1 has to produce a 0, right? Because on Intel processor, that would require, emitting some branch code, right, to test for these values, and do something appropriate. And so they basically allow implementations to sort of have their default behavior instead of forcing a particular behavior on it, right? So that's the second use of undefined behaviors, to give this license. And the third use, which is probably the least understood is that sometimes it's just there to allow implementation extensions, right? So if you do something like fopen on a file, they're a set of defined mode characters, and if you specify a mode character that's not defined by the standard, that's undefined behavior, right? So if you do that, nothing particularly weird is going to happen. But what happens is, you've got these file systems with really varying capabilities, and security tends to be one of those, right? Default permissions, things like that, the mode you want to open the file in. And so, the C standard, and presumably C++ as well, makes that undefined behavior so implementations can add additional mode characters in order to access those additional features of, their specific file systems. Yeah. And, we just added unreachable in C. And that basically is a way of allowing the user to inject undefined behavior into the program to help with optimization, right? So that's now a user feature that got voted into C23. So there's support for that because, C compilers and users like to optimize code, right? They like to have highly performant code, and this can help with that. But there are standards like MISRA, which just say no undefined behavior, right? So you couldn't use unreachable in a MISRA conforming program, or use a mode character besides the ones defined by the standard for a call to fopen, which actually means that your MISRA conforming program can be less secure, right? Because you're not able to access some of these additional mode features that would improve the security of your program. And hopefully that's something MISRA will get around to fixing, as they kind of extend to sort of more complex systems, having kind of Linux as a operating system on safety critical systems and so forth.
I guess, is that something you might be kind of focusing on more in your new role, working on MISRA standards?
Yeah, I think I'm supposed to get more involved in that. I know the MISRA guys have been asking me for a long time to help them out, and it's not actually a public standards body. So I keep saying sure, and asking them to pay me, and they don't seem to have the money. So, but I guess going forward, it sounds like Toyota will or Woven Planet will, pay me to help develop MISRA standards. So that should be fun.
MISRA is specifically used in automotive, is that correct?
Well, it was originally designed for automotive. It's a motor industry standard for reliability, and I'm not quite remembering the acronym, but I think originally, I might be getting this wrong. It might have been Rolls-Royce and Jaguar in the UK both had safety standards for C, and they decided, it would be easier if they sort of combined them and then handed it off to a different organization to manage for them, to kind of, reduce costs of maintaining these standards. So that was the origin, and it's been managed by sort of independent companies. I'm not sure. It might have been a recent change that I haven't kept up with to the governance of MISRA. But yeah, until recently, it's sort of been managed by these private organizations.
And your books, several of them are on, say, Cert in the title, and I think we've mentioned that a couple times, but what exactly is Cert?
Yeah. So once upon a time, CERT stood for Computer Emergency Response Team.
Okay.
But with all acronyms, eventually people discover that you cannot copyright or trademark an acronym, and so CERT no longer stands for anything. It's just CERT.
Okay.
Yeah, same thing with JDBC. It no longer stands for Java Database Connectivity. It's just Jibica. I mean, so CERT is just CERT.
I didn't even know there would have been a reason to worry about trademarking JDBC, honestly. But
yep. Yeah, I started my career with IBM, and they had that problem. They couldn't trademark IBM because it's an acronym. So they made a little blue logo thing, and they trademarked that. And I remember somewhere in the Hudson Valley there was a winery, and they reused like that logo for the winery, and IBM just sued them into the ground. I mean, they're very aggressive about protecting their name and their trademark.
So the books that you have that are about CERT, is that a specific set of standards also?
Yeah, so we I'll tell you the story of this, since you asked. So I was at a C standards meeting in Berlin in 2006, and I had some members of the C committee approach me with the idea that CERT should develop a secure coding standard for C, and because they had issues with MISRA at the time, perhaps more so than now, right? So part of their issue with MISRA was that MISRA had thrown the baby out with the bathwater, in particular by not supporting recent versions of the C standard. Right? So I thought that was a great idea. So I flew back to Pittsburgh, and we started work on that. So we set up wiki pages for secure coding in C, and secure coding in C++, and secure coding in Java. And the C was probably the first one to get completed. And then we published a first edition of that with Addison Wesley. Try not to buy that, or if you bought that, throw it out. It was it was a first go. It was a learning experience for us. But subsequent to that, we started a study group in WG14, which went on for 3.5 years. And we produced a technical specification. I want to say 17961, but I'd have to check I got that number right. And also produced the second version of the Cert C secure coding standard, which is pretty solid. It really has held up since publication. Yeah, and then Aaron Ballman, was working for me at Cert, and I had both Aaron Ballman and David Keaton working for me at Cert. So Aaron Ballman completed a C++ coding standard, but it's been published by the SEI. It's available on their website. Has not been published as a book. And we worked with Jim Manico. I don't know if you know Jim, but he kind of got us started on a Java secure coding standard. And then I had a student who wanted to work on the Java coding standard as a thesis, as a master's thesis project. So I said sure, and he did a very nice job. I gave him an A. And he came back to me and he said, "Sir, you do know that you can also give me an A+." And so I said, "Oh, I didn't know that." So I gave him an A+. That's Dhruv Mohindra. He's back in Pune, India, but we keep in touch.
Okay. Well, Robert, it was great having you on the show today. Thank you so much for talking to us about secure coding and integers. It's great having you on.
Thanks. I had a good time.
Definitely could have spent more time on the secure coding aspect. So, but we got to talk about integers.
Yeah, we got secure coding and integers are the same thing. So, yeah. I mean, because when you talk about C and C++, the biggest issue tends to be accessing objects outside the bounds of the object, right? That leads to arbitrary code execution, and the way you get the way you manage to access a object out of bounds is you take a pointer and you add it or subtract an integer from it, and then you dereference memory at that location, right? And so if you've lost control of your integer values, right, now you're accessing memory out of bounds. And so a solid understanding of integers is really kind of at the core of secure coding. I mean, you cannot you can write a C or C++ program that doesn't do file IO, but you can't write one that doesn't use integers.
Right.
It's very true. All right. Thanks, Robert.
Thanks a lot.